All right, so our first activity here in 4.5, negative exponents and reciprocals. We have a rectangle, and the area is 1 square foot. And the question is, list 5 possible pairs of lengths and widths for this rectangle. Now, I mentioned that 1 times 1, although that doesn't fit this diagram per se, because when you have 1 tick here and you have 2 ticks here, it means that they're different lengths. So 1 and 1 technically would work, because 1 times 1 is 1. But what's one other pair that you guys had? Just anybody, shout out one other pair. And I'll put it on my diagram. Go ahead. Anybody? Length times width equals 1, other than 1 and 1?
4 and 0.25.
Okay, thank you. 4 and 0.25. Okay, does that work? 4 times 0.25, does that equal 1? Okay, so let's write this down. 4 and 0.25. Okay, very good. What's another pair? Just quickly fire them off here. 2 and 0.5. Okay, so 2 and 0.5. I like it. Okay, another pair?
5 times 0.2.
All right, 5 times 0.2. Does that work? Everybody check that out? Okay, so if we have a number that's greater than 1, we're multiplying by a number that's less than 1. Everybody notice that? Okay. I wonder, could we write these decimals in fraction form, please? So what's 0.25 in simplest sort of fraction form? That is what? 1 over 4, okay. What is 0.25 in simplest fraction form? 1 over 2, okay. Any guesses on what 0.2 is in simplest fraction form? Yeah, it's 1 over 5, okay. 1 over 5. Now, if we multiply these together, guys, okay, so watch this. I'm going to change color here, down here. If we multiply these together, 4 times 1 over 4, that's going to equal 1. 2 times 1 over 2, that's going to equal 1. 5 times 1 over 5, that's going to equal 1. Okay. So once we get to this point right here, we can see that we have a number, and then we have a number that's really that's related to it in that the number in the denominator is the same. You see that? And we also have a 1 on top. So what happens, let me change colors again, what happens when we have a to the m times a to the n? Okay, what happens when, what's the exponent law there? What is it, a to the power of what? M plus n. Okay. So here's my question. If I take this number 4 to be this one, how can I write this in a power form? What would the exponent be on 4? 1. Okay. So I am looking for another pair here to represent this 1 over 4. And keep in mind that if we're talking about a and a over here, this has to be 4. What is 1? 4 to the power of what equals 1? 4 to the power of blank equals 1. Anybody know that? Okay, you guys got to know that one. Got to know that one. It's 4 to the power of 0. Have you ever been told that before? Okay. That will come up again here. We're going to talk more about 0 exponents here. I think soon. Okay. So anything to the power of 0 is 1. Unless that anything, that base is 0, then that's no good. But any number, any variable, anything to the power of 0 is 1. So watch this. 1 is the same as 4 to the power of 0. Now, what would this number have to be in order for this exponent law? This is very important. Everybody pay real close attention. I have 1. This is 1. M is 1. And I know that m plus n is 0. So what does n have to be? how would I fill this blank out here? 0? N would have to be 0? So 1 plus 0 is 0? Not quite. Negative 1. So if I was adding something to 1 to get 0, it would have to be negative 1. And what's the other part of this rule? That all the bases have to be the exact what? Same. So guess what, guys? Okay? That's what this actually is. Right here. 4 to the negative 1 is actually the exact same as 1 over 4. Very important. Okay? 1 over 2 is equal to what then? 2 to the power of what? Negative 1. Yeah. 1 over 5 is equal to what? 5 to the power of? Negative 1. Okay, so now you're seeing how negative exponents, how negative exponents sort of work. Okay, let me show you this one. Here's another one. 16 times 1 over 16 should equal 1, right? That's 16 over 16 is 1. 16 is 4 squared. 1 is 4 to the 0. So what is 1 over 16? That's got to be 4 to the power of what? Negative 2. Negative. So because 2 plus negative 2 equals 0. Everybody see that? So 1 over 16 equals 4 to the negative 2. 1 over 16 could be written like this. Okay? So I'm showing you all this to say, now I'm not going to make you reproduce this explanation. But what I want you to know is this, is that when you have a number or a base with a negative exponent, you can make that exponent positive by taking that whole power, if it's in the numerator, the top part of a fraction, bring it down to the bottom. Everything stays the same except the negative is gone. Okay? Or if you have a positive, so watch this. 4 squared equals 1 over 4 to the negative 2. So when you have an exponent in a power and you automatically flip it down to the denominator in the bottom, you change the positive and negative nature of the exponent. So let's just give this one a real quick test. 16 equals 1 over, what did we say this was? 1 over 16. Because look at what 4 to the negative 2 is. It's 1 over 16. So have you ever seen this before? Well, hopefully. Do you guys remember the rules when we're dividing fractions? There's a rule. When you divide a fraction, what do? You blank and blank. Anybody know that one? When dividing fractions, you reciprocal. Okay, that's the fancy word for it. Yes. But what do you do with the reciprocal? You what? Okay, flipping is the reciprocal. Okay. What do you do with the reciprocal? When you're dividing by a fraction, you do what with the reciprocal? You multiply by the reciprocal. Okay. So this is the way I learned it when I was your age in school. When you're dividing by a fraction, you flip and multiply. You flip, and turn that division into multiplication. So this is like this. 1 times 16 over 1. See, the 1 over 16 gets flipped. Okay? Now, a student came back to me and said, I told my mom what we did at school today, Mr. Maxwell. I told my mom that you said that when we divide by a fraction, you just flip and multiply. And she got after me. She thought I was cussing. You know, like flipping is a substitute for another word. Okay. Anyways, that was sort of a joke. A few of you laugh.
That's funny.
Thank you. All right. Okay. So you flip and multiply, man. So 16 does equal 16. That's true. Okay. So negative exponents. What's the rule? The rule is, after all of that, drum roll, please. Thank you. X to the negative n equals 1 over x to the n. Yes way. Now we have a condition here, of course. X cannot be 0. Because remember, you still can't divide by 0. So please remember, you still can't divide by 0. X can be anything but 0. Also, x to the n equals 1 over x to the negative n. So the positive, negative nature of the exponent, it changes when you flip it from the numerator to the denominator. Okay? So here are some examples. Okay? Here's some examples. What is 7 to the negative 2? Someone tell me what that is. As in fraction form, that's going to be what? 1 over 7 to the positive 2. Very good. Which is what? If I would ask you to evaluate that to a number answer, that would be 1 over 49. Very good. Okay, awesome. Okay. What's another way to write this? 1 over 2 cubed. How can I write that a different way with, like, not in fraction form? So I don't want 2 to the 3 in the denominator. 2 over negative 3? Not quite. Almost. 2 to the power of negative 3. That is exactly correct. Very, very good. Okay? Very, very good. Okay. I think you guys are getting it. Now, it's important to note that this negative part, or the sign on the exponent, only deals with, this exponent only deals with the variable or the number that is immediately before it. So when we have something like this, watch this. If you have a to the power of 3 times b to the power of 2 times c to the negative 2 times d to the 4. And I want you to write this in a form where there are no negatives in the exponent position, only positive exponents. You would not do this. It doesn't equal this. 1 over a cubed b squared c squared d to the 4th. You don't bring everything down. Not this one. Okay? Instead, you say this right here has a positive exponent. Good. This one has a positive exponent. Good. This one has a positive exponent. Good. This is the problem. So this part of this term, c to the negative 2, that's the one that can get moved. So this actually equals a cubed b squared d to the 4th divided by c to the positive 2. Okay? So you only take down that which is, negative if you want to make it all positive. Okay? Continuing on. Okay, what happens if we have fractions? Okay. So, what happens if we have 3 quarters to the power of negative 1? How do you deal with this? Well, what you could remember is when you have a fraction and you have an exponent, that exponent applies to the numerator and the denominator. So this is actually 3 to the negative 1 divided by 4 to the negative 1. Everybody okay with that? Now, if I want to write this with a positive exponent, this 3 to the negative 1 goes from the numerator down to the denominator as a factor. This 4 to the negative 1 goes from the denominator up to the numerator. So really, a negative 1 speaks of a reciprocal. Anything to the negative 1 is the reciprocal. You just flip it. Top and bottom, you flip it. Because this becomes 4 to the positive 1 over 3 to the positive 1. 4 over 3. You see that? So if you have 3 over 4 to the negative 1, that is 4 over 3. Okay, what's 2/3 to the negative 2? Ooh. Okay, 2/3 to the negative 2. Evaluate this. What does the negative tell us to do with a fraction? Negative exponent? Flip them. Okay? So let's get rid of the negative first. So we're going to go 3 over 2 to the power of positive 2. You see how that negative flips the fraction? Now we haven't dealt with the 2 yet, we just dealt with the negative. Now this is 3 squared over 2 squared, or 9 over 4. Okay? So the negative flips, and then the other, whatever the number is, that's, you just take your squared or cubed or fourth, whatever. Okay? All right, any questions so far? So this will be the final example I'll give you before I let you go on your assignment. This is one of the tougher questions on your assignment towards the end, so I want to know if you can do this. So this has everything in it, okay? We've got a fractional exponent, which we talked about already. We've got a negative inside there. We've got a negative exponent here, okay? There's a little bit of everything. So what you do is, okay, and I should probably I'm going to give you 30 seconds to come up with your answer with this. 30 seconds. All right. So, got a few seconds to take a look at this. Let's put it all together. I'll show you how I would do this. So first of all, this negative, let's get rid of the negative. Okay? It only does one job on a fraction. It flips the top and the bottom. Don't do this. Don't say, hey, a negative times a negative becomes a positive. You can't do that. And if you did that, okay, then just know that next time you can't do that. This is not multiplying. That negative actually stays exactly the same place. So this becomes negative 27 over 8 to the power of positive 2/3. So the negative inside the brackets does not change. Okay? Now, the negative can be attached to either the top or the bottom. It doesn't really matter. The next thing you'd want to do is look at this here, probably. Right? That means what? What does a 3 in the denominator of an exponent mean? Take the what? Cube root. Okay? Take the cube root. So we're going to do this. We are going to do the cube root of negative 27 over 8 to the power of 2. Everyone see that? Now, I'll show you the step full out. You don't have to write this one generally when you're showing your work, but this is what it looks like. You can take the cube root of the top and the bottom, which turns into cube root of negative 27 is going to be what? Negative 3. What's the cube root of positive 8? That's going to be 2. And we are squaring that. So squaring that actually means, right, negative 3 over 2 times negative 3 over 2, right? So you get positive 9 over positive 4. Okay, anybody get that for an answer? Okay, good. You got it for an answer now that I've done it? Okay. All right, so that's putting everything together, all right? That's what we've done the last few sections. Okay, so that's the lesson for today. As far as your assignment goes, so 3, 6, 7, 8, 9, 10, 13 is the assignment for today's class, anyways. I'll show you a little bit of this textbook here. So if you're at home and need to see these questions here on the video, then I'll just show them up here for you, okay? Here's the first 4. And there's some more word problems on the next page here. You can give any one of these a try just to kind of strengthen your skills here. The ones in the C section are a little bit more challenging. So I would encourage you, if you are doing really well in this is really easy for you, anybody, do some of the C questions, okay? Just to make sure that you're getting challenged, okay? And you can do that on your own. Okay, so there's your assignment again.